Dear students, this is Dr. Biju Devan, and in this video we are going to discuss the chapters 1.4 Measures of Variability, 1.6 Statistical Modeling, Scientific Inspection and Graphical Diagnostic. These two topics are falling in week 2 of the regular semester, but they fall in the first week of the summer semester. Measures of variability, measures of dispersion, in other words, how far the data are dispersed from the mean. That's the meaning of this chapter, right? A measure of spread helps to tell us more about the data. It gives a feel how much variation is there in the data. It tells us whether the values are clustered close to the mean or median or spread out. Now, process variability is a huge consideration in manufacturing. Are you filling all your water bottle with about the same volume of the water, or is there any variation? How much difference is there in generally between the volumes of any two randomly chosen bottles? These are the real life usage of this variance. Now the concept of range we are considering. Range of data is the difference between the maximum value of the data set and the minimum value of the data set. If you assume that you have a sample of five elements, 2, 8, 10, 12 and 14, isn't it? This is your sample. So maximum value is 14, minimum value is 2. So 14 minus 2 is 12. 12 is your range. The difference is in ascending order. The data has been arranged in ascending order, and the difference between the maximum and minimum value is called range of this sample. Now the formula for variance. Variance, you know how far the data has been dispersed from the center, from the mean or median, right? So now the formula for variance. For sample variance, the notation is S square. Population variance, it is sigma square. And there is a standard deviation. Standard deviation is square root of variance for both sample and population. So the summation of the squares of the differences and divide the summation by n minus 1. N minus 1 is the degrees of freedom. If there are data size is n, degrees of freedom is n minus 1, isn't it? So that is it. Okay, so the sample, that is the formula of variance. What you got to do here? Xi, x1, x2. So what is the point here? How do you calculate variance? I give an idea. Again, you assume that you have a data 2, 4, 6, 8, 10, isn't it? And 18. This is 10, isn't it? 18, 24 is 30 divided by 5. So the average x bar is looking 6. Yes, sum them up. 18, 28, 30. 30 divided by 5. What is the formula for average x bar? Sum divided by number of elements. So this is 6. X bar is 6. This one. Now how do you calculate this s square? Roughly I give you 1 over 4. N minus 1. N is 5. There are 5 elements. And now first element xi, I varies from 1 to n. So n is 5. x1, x2, x3, x4, x5. There will be 5 elements. X bar is given here. So first element minus the mean. 2 minus 6 whole square. Second element 4 minus 6 whole square. Third element 6 minus 6 whole square is 0, plus 8 minus 6 whole square. Finally 10 minus 6 whole square. Now if you calculate this one, you get the variance. Let's see. 1 over 4, this is 2 minus 6 is negative 4. Negative 4 square is 16, and 4 minus 6 is negative 2, which is 4, plus This is 0, leave it. 8 minus 6 is 2, 2 square is 4. Again 10 minus 6 is 4 square is 16. So 20 plus 20, 40 divided by 4, your variance is 10. Variance is 10 and the square root of variance is standard deviation. Standard deviation is sigma. Square root of 10, which is around 3 point something. You can take a calculator and check what is the square root of 10. 3.16, isn't it? So how far the variance? Variance is 10. Variance is too big. One data is 2, another data is 10. So from average they are different. More than 3.5 difference. 3.16 minimum average. So the derivation, this is the mean, and your standard deviation is 3.16 standard deviation. Alright, that's what we find. That's the way we find standard deviation variance from the given data. Okay, so some information about the mean and variance. A small variance indicates that the data points tend to be very close to the mean and to each other. High variance indicates that the data points are very spread out from the mean. Yeah, here the previous time they are not very close. If you find all data are 5.9, 5.6, 5.8, then you know that the data is very close to the mean. But here data is spread out, so the variance is very high, which is 10. Is moving out in both sides. It will move. If you continue the tendency, it will be 12, 14 in the right side, negative 0, negative 2 in the left side. So they are moving away from the center, right? They are not very close to the center. That's the meaning. A low standard deviation indicates that the data points tend to be very close to the mean. High is the same, because mean standard deviation after all the square root of the variance. If the variance of standard deviation has a value 0, all the values are identical. There is one similarity between these two values. The standard deviation and the variance always will be non-negative. There is no negative value for variance and standard deviation. The question may arise that at the time of calculating variance, why should we square? You might have understood now. When you square, is the difference negative sign will be positive, isn't it? Okay. And it weighs outliers more heavily than the data closer to the mean. To this the reason, and now let's go to the exercise problem. First exercise problem. The data is same as we have discussed in the chapter exercise 1.1. Here the question is find sample variance. Here the question is find sample variance and sample standard deviation. That's it. Okay. The idea is, we know we have to write this one ascending order. We know the sample mean already, but we write it one more time. This is 2.5 plus 2.5 plus 2.8, again 2.8, again 2.9, 3.0, 3.3, 3.4 plus 3.6 plus 3.7 plus 4.0, 4.8. I'm writing in actually ascending order. 5.2 plus 5.6. Can you check all the 15 elements are there? 3, 3, 6, 8, 10, 14. Is it? Anything is missing? 2.5, 2.8, 2.8, 2.9, 3.0, 3.3, 3.4, 3.6, 3.7, 4.0, 4.4. 4.4 is missing. So let me write this 4.4 here. Okay, 4.4. in ascending order, we have already found for the data mean and median. We can check back, and now when you add and divide the entire data collection by the total number of elements. When you divide this set by the total 15, and then which is sample size, what you get is what you get is 3.787. This is your mean x bar. So we need mean to find the sample variance, isn't it? Okay. Now what should I do to find the sample variance? Let me explain you another sheet. Can I clear this one? So write down them. So we know the formula for variance. I'm writing here. The formula for variance x bar is 1 over n minus 1 summation n from I is from 1 to n xi minus x bar whole square. Xi, every element in the set. So first element minus the average square, second element minus the average square, third element minus the average square. It will be done for all the 15 elements, and sum the total and divide by n minus 1. N is number of elements in the data set, 15. So n minus 1 is 14, isn't it? Now we are going to see this this in the sheet. What is it? Summation, so variance. Now we are finding variance. The notation is s square, sample variance. So I am writing 1 over n minus 1 is 14. Open it up. First element, what's the smallest element? I am going from the smallest element, 2.5 minus the average is 3.787 whole square. The next element in our ascending order is 2.5. You don't need to make it ascending order. You don't need to make it ascending order. You can do with the same order, but for my convenience I have done it. Right? If you want to find median, you can easily find if you are in the ascending order. So 2.8 minus 3.787 whole square. This should be done for all the 15 elements in the data set. So do it for every term. The last term, the highest value is 5.6 minus 3.787 whole square. Now use calculator for this one. Every term should be subtracted and then squared for 15 terms. So the answer when you use your calculator will be 0.94284. This is the sample variance. Now what is the next question? What is standard deviation? Standard deviation is S. Standard deviation is S, which is square root of the variance. So square root of 0.94284 is again 0.971. That is standard deviation. That's done. So we are done with this problem. The next one is, the answer is given here. Compute the sample variance and standard deviation. We have done it for two problems, and here there are many elements in this sample set. So check 1, 2, 3. So 2, 3, 4, 5, 6. 6 3s are 18 plus 2, 20 elements are there in this sample set. So here n is equal to 20. Manually it will be a little bit risky, but using SPSS we can do it very easily. Okay. So again, find the sample mean, sum all the data divided by 20, isn't it? And what is the formula for S square, the variance? 1 over 20 minus 1, 19, and start. You should have the mean here. If you find the answer is on the next page, you can check your answer. The So the mean is 20.768. So the mean here is 20.768. So this mean can be subtracted from every element here, 18.71 minus 20.768 whole square, isn't it? Do this for all the elements. The last element here I am taking 22.87. So 22.85 minus this is 22.85 minus 20.768 whole square, the last 20th term, and when you do this one you find the variance which is given under. The variance is 2.536345, and when you take the square root of the variance you will find standard deviation which is 1 point. So they are almost near. The variance is not bigger. Standard deviation also so somewhat near, so the data are somewhat close to the mean. That's it. Now let's go to the next one: statistical modeling, scientific inspection, and graphical diagnostic. One of the primary goals of this statistician is to use sample data to make predictions about the population parameter. That's what we have seen in the introduction chapter, isn't it? So population mean, population variance, etc. are called population parameters. This is called statistical inference. Now, this section we examine how to summarize sample data in various types of displays in order to make our job of statistical inference very easy. We look at 4 types of displays. Scatter plot. You see the graph. Scattered, isn't it? It is every point is a XY coordinate system. In a XY graph, we should have 2 variables here. You can see 2 variables. One variable is independent, another variable is dependent. Cost is dependent on the quantity, isn't it? So if the quantity is 23, the cost is different. The quantity is 42, the cost is different. So this is independent variable, this is dependent variable. So x and y, you can say this is x and this is y. Y is a function of x, y is depending on x. Now volume has been given x-axis. If the volume is 20, there is no 20 here. The 23 is the minimum value, I think. 23 between 20 and 30. This 25 somewhere here 23. So 23, the cost is 125. 125 is above 1. So this point is 125. In this way, every pair has been plotted on the graph. This is called, if you get a pair of data of independent and dependent variables, you can present them on the xy plane as a dot. Every x and y will be presented as a dot on the xy plane. This kind of graph is called scattered plot. Now you understand, just go through this one. Different names: scatter plot, scatter graph, scatter chart, scattergram, scatter diagram, scatter plot. So these are mathematical diagram using Cartesian coordinates to display values of typically 2 variables for a set of data. It shows a relationship between the 2 quantitative variables, dependent variable and independent variables. That's it. Go ahead. Stem and leaf plot. We have a data set here. So this is our sample. How many elements are there? Just count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 elements. And first 2 are starting with 1, ending with. So start first this stem, and you can write 5 or 6. So under 1 there are 2 elements. 2 elements are starting with 1. So 2, there are 1, 2, 3, 4, 5. So second elements are leaves. First element is stem. Isn't it? 1, 3, 3, 6, 6. 1, 3, 3, 6, 6. So this can be considered as 21, 23, 23, 26, 26. Isn't it? That's it. And finally 30, in 30s there are 2, so 3, 0 and 2. 40, there is only 141. In this way, if you represent the data, it is called stem and leaf plot. We have a different example as well. You can see this. The scores of class test are given below, and its stem and leaf diagram is also given. See, the data are scattered, so you just check what is the minimum value. Is it 7? Is it any other value lesser than 7? Just 5. These are lesser than 10, so it starts with the 0, 0, 5, 0, 7, only 2 data, and starting with 1, above 10, less than 20. What do you mean, isn't it? So 12, 17, 17, 19, 19. You mean that there are 5 elements between 10 and 20. Check it. Yeah, there is 117, another 17. In the ascending order, we should have checked it. 12. Oh well, there's 19. Of course, 19 should have been there. Where is it? Yeah, we got it. So that is it. Okay, first write them as intervals 0 to 10, how many? 10 to 20, how many elements? Then you can easily write them into stem and leaf. But if the data set has more number of elements, more than 100 or 200, we can easily use SPSS to find the stem and leaf diagram. Okay. Histogram. Histogram is a graphical display of data using bars. Everything is a graphical display of data here, but here we are using bars of different heights. In histogram, each bar groups the numbers into ranges. The taller bar shows that more data falls in that particular range. For example, if you get 0 to 10, 0 to 10, 10 to 20, 20 to 30. If you write a bar chart, this is histogram like this. Here what do you get? Assume that this is 5, this is 10, this is 50. In this interval, there are 5 elements of the data. 0 to 10, there are 5 elements. From 10 to 20, there are 10 elements. 10 to 20 to 30, there are 15 elements. That's the meaning. Okay. The shape and the spread of the continuous sample data is given here. Grouped data histogram. Weight of NBA players. 12 classes. There are 12 intervals. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 and 12. This is between 157 and 69. This is between 69 and 181, 81 to 93. This way interval has been found. Well, finally, the last interval is 289 to 301 pound. Pound is something. I don't know what is the unit given. No, unit has been given. Just given as weight. Okay. Now there are 5 members with this weight, and there are 34 members in this weight category. The maximum number of members, 98 members, are falling in this weight category, 229 to 241. So this representation of the data gives a clear picture of the quality of the data. There are many characteristics of the data can be identified here. This is called histogram. Box and whisker plot, or box plot simply. And this kind of graph shows quartiles. We have seen what is quartile, isn't it? Quartiles 1 and 2, 1, 2 and 3. Where the quartiles, the data can be split into quarters. So quartile 1 is 25%. 25% of the data will fall. First 25% of the data will fall below the Q1. That is called the quartile 1. Quartile to 50% of the data will fall below this number. Quartile to 73%. So we are splitting into quarters. So this diagram represents the quartiles, and the highest and the lowest value will be separately shown here. This is this can be drawn by SPSS very easily. Now the data is symmetric or skewed. If you can find the data is having a normal curve this way, it is called a symmetric data. If this is written this mode is oriented toward the right, it's called a left skewed. If this is oriented toward the left, we call it right skewed. There is nothing in the right, isn't it? So this kind of graph, normal curve, will show you symmetric, otherwise it is skewed, either left or right. Exercise. A tire manufacturer wants to determine the inner diameter of a, what's the question? Yes, some data has been given, tire, they are diameters of the tire. Diameter would be 50. Okay, the data given here, there are 8 elements. Check 1, 2, 3, 4, 5, 6, 7, 8. So sample size is 8. The question is sample mean and median, variance, standard deviation, range. Range is the maximum difference between maximum and minimum. Okay, we will again do this one. Okay, what is the mean? X bar. Start from the first one. There is a minimum most value is 565, 568, again 569, 570, 572, 572, 573. How many? 3. There are 3 and 4. 3. What did I miss? And 5, 7, 5. Divided by 8. I have written ascending order divided by total number of elements. The answer is 570.5. So the average is 570.5. Now median is middle value. There are 8 elements. First 4 here, next 4 here. So the middle value consists of 2 elements, 570 and 572. Therefore, what is median? X tilde. 570 plus 572 divided by 2, which is 571. This is median, and mean is 570.5. So mean and median are closer. Mean is 570.5. Median is 571. They are closer. Now standard deviation, range. Okay. What is the way to find standard deviation? Let's clear this one. So mean is 570.5. Remember it. We use this mean to find standard deviation. Standard deviation is S square. First variance. 1 over 8 minus 1, 7. Open. First data. Smallest one, our count is 5. Some technical troubles, let me correct it. Okay. The variance S square is 1 over 8 minus 1, 7, and the minimum data value is 565 minus 570.5, the mean, whole square. Do it for all the 8 terms. The highest term is 575 minus the average 570.5 whole square. Do it for all the terms and you will find the variance is 10. Therefore standard deviation is square root of variance. Square root of 10, which is 3.162. See, the variance is high, more high. Therefore, they will not be uh, closer to the mean. The data is not closer to the mean and median. The answers are given here. Okay. Next we have yet another different problem. Maybe the last problem of this chapter to discuss here. The following scores, so there are plenty data elements. Manually it's going to be typical, isn't it? Okay, final examination grades for elementary statistics are given. 1, 2, 3, 4, 5, 6, 7 in a column. 1, 2, 3, 4, 5, 6. 7s are 42 and there are 3 columns with 6 each. 18. Totally the sample size n is 60. There are 60 elements in this sample. So computing mean, sample, median, sample, standard deviation has been left to you. Try when you are completely free. Okay, I am going to construct a stem and leaf plot for this data, and I will try to construct relative frequency histogram. That is what the purpose of this particular problem. Okay. Now keep the data in mind. Let's write stem and leaf. Now you need this data in front of you, so that I can go to I write the stem and leaf here. Stem and leaf, isn't it? So what is the data set? Always you should refer the data set. From the data set you should know what is the minimum value. There are 60 and probably all the elements are between 0 and 100. So I can classify them into between 0 to 10. So there will be, the stem should be 0. Between 10 to 20 the stem will be, so my stem are 0, 1, 2, 3, 4, 5, 6, 7, 8 and 9, because there is no 100, only 2-digit elements we have, isn't it? Now we have to count how many elements are starting with 0, one single digit elements in this collection. Those single digits are available. Well, anything is there? No, there is nothing starting in the single digit. So obviously there is no need for the stem of 0. Now the stem is 1 digit, double digit, starting with the 1. Search it. What are they? There is anything here? No. Here 10 and 10. Here 17. Is that all? 10, 15 here. 10, 15 and 17. There are 3. So 1 is stem, leaf is 10, 15, 17. So 1, 0 will be 10, 1, 5 will be 15. So 3 leaves we found. There are 3 elements. Now between 2 and 20 and 30, starting with the 2, isn't it? Count. So in this way we have to count. This way. How many 20s? 23. Any 20 here? No. 3. There is no 20 here. No. Let me check one more time. Did I miss anything or what? Only 123. So I think only 1 leaf. Did you find anything else starting with the 2? Yes, 25. Here, 23 and 25. So first 1, 2 leaves 23, here 23, 25. 5 for 25, isn't it? Now starting with the 3. I just try the answer, we check it. There are 32, 34 and 36. I have found the answer. There is a 41, there is another 41, there is a 43 and there is a 48. In this way you can collect for all of the elements. This is stem and leaf representation. Okay, and you know how many elements are there, the frequency. How many elements are there in every frequency? There are 3 elements with the stem 1. The stem 2 there are 2 elements. The stem 3 there are 3 elements. The stem 4 there are 4 elements. In this way, with the stem 5 there is 52, another 52, 54, there is 55, there is 57. So there are 5 elements with the stem 5. For 6, 7, 8, 9 you practice and check how to write frequency and leaf. Right? This left to you. Next work is the construct a leaf. I mean, it's given here. Construct a stem and leaf plot for the examination grades with the stems are starting from 1 to 9. I don't need to check 0. Obviously, it is 1 to 9. Next is construct relative frequency histogram. This stem and leaf will give us an idea here to write the classes for the relative frequency. Okay, let's go ahead. Another page we will go. Okay, we'll erase all this thing. Fine. Now this is for relative frequency histogram. Now let's go check the question, isn't it? Discuss skewness. We will discuss later skewness. Draw an estimate of the graph of the distribution for construct a relative frequency histogram. Estimate the graph of the distribution. Okay, we will do it. First, you should have the classes here for relative frequency. We need to know to construct the histogram. We need the midpoint of the interval as well. Okay. First thing we are going to do is writing class interval. CI stands for class interval. And now midpoint. And then frequency, how many elements are falling in this interval. And then finally relative frequency, right? Class interval means here there is no single digit element, so we can start from 10 to 19 and then 20 to 29. The number of the elements within this one, how many? We just need to count it. From the stem and leaf we can get the count, isn't it? Okay. Midpoint of this 10 and 14. Sum the upper and lower parts and divide by 2. 10 plus 19 is 29, divided by 2 is 14.5. So the midpoint for 20 to 29, the midpoint is 24.5. Next interval 30 to 39, the midpoint is 34.5. Just add, once you find the first midpoint, add a 10 to it, you will find it. 40 to 49, this will be 44.5. 50 to 59, 54.5. 60 to 69, it is 64.5. 70 to 79 is 74.5. 80 to 89, 84.5. 90 to 100, 100. This is 94. Actually, it should have been 99. We have only double digit data. There's no 100. 94, 94.5. Now frequency. How many elements are in the data between 10 and 19? Go and collect it. From the relative frequency, you can easily collect the answer of this one. Here. Here you can have the answer of stem. So this will give you the output. Frequency. How many elements are on the first club after 10 and between 10 and 20? 3, 2, 3. That's our frequency here. 3, 2, 3, 4, 5. So here this is 3, 2, 3, 4, 5. It means there are 5 elements between 50 and 59. You can check here in the given data set. Let me complete this one. 11, 14, 14, 4. 11 between 60 and 69. 14 between 70 and 79. 14 between 80 and 89. 4 between 90 and 99. Isn't it? Check this sample. 50 to 59. Go back. Yes. How many 50s? 1, 2, people here. 3, 4, 4. That's it all? 4 or 5. Between 50 and 60. One here 55. Here there is nothing. Here 52, 2. Here there is nothing. 57, 3. 3. Here there is no 50. 4, 5. Here 52 and 54. 5 elements are there between 50 and 60. That is it. That's the meaning. You can do. Now we have written the frequency. Finally, we are writing relative frequency. How do you find relative frequency? Divide the frequency by the total number. Frequency is 3, total number of elements is 60 and sample size, isn't it? So use calculator. Check what is 3 over 60. Use calculator. Check what is 3 over 60. 3 divided by 60 is 0.05. So now this is 2 over 60, which is 0.03, and again 3 over 60, 0.05, 4 over 60, 0.07, 5 over 60, 0.08, 11 over 60, 0.18, 14 over 60, 0.23, 0.23 again, 4 over 50 already we have seen, 0.07. That is relative frequency. Now we are going to draw relative frequency for this, that is histogram for the relative frequency. Histogram, the x-axis will represent the midpoint and y-axis will represent the bar chart, that is the rectangular box will represent this height, 0.5, isn't it? That is shown here in this graph for you. You can put your this one and come again to slideshow present. This is your frequency table, isn't it? Relative frequency table, and now we get the graph here. See the midpoint for first interval 14.5, for second interval, third interval, fourth interval. So all the fixed final exam grades, intervals and its midpoints. Now this height shows 0.03, 0.0. So Here this height is for 0.05, this height is for 0.03, this is again 0.05 relative frequency, this is 0.07, this is 0.08, this is 0.23, here against y-axis you find 0.23. Now this is 0.18, and then 0.23, 0.23, here you will find 0.07 equal to this. Isn't it? All rectangles are showing the relative, the height is showing the relative frequency. Now if you roughly draw a curve, a normal curve touching the tops roughly, it will shows that it is left skewed. Skewness is towards the left, so this is not a symmetric curve. Finding mean, median and the standard deviation has been left to you, or you can take the data, use SPSS and check this one. Thank you very much.